Hey, I'm Eric, a member of the Teenage Advisory Board with the Howard County Library System, and today I'm going to go over part 2 of libraries, in which I'll be introducing a new Python library called Pandas. I am also partnered with the chspyoneers, a school-based club, and our mission is to spread our passion for programming and inspire others to code. So let's get started. To begin, what exactly is Pandas? Well, Pandas is a software library written for the Python programming language for data manipulation and analysis for tabular data. And in case you don't know what tabular data is, it's basically data that's structured into rows and columns. Panda provides a really fast and efficient way to manage and explore data. So if you want to become a data scientist or analyst, it's recommended that you get yourself familiar with this library. And since I'm going to be using Repl.it to demonstrate everything, I actually won't need to install Pandas, but if you're using an IDE, such as IDLE if you're on Mac, or PyCharm, you actually have to go through an installation process. I'll put a link in the description for the process if you guys want to go install it. But once you have it installed, you can import Pandas by using the syntax import Pandas. Okay, as mentioned before, Pandas has two data structures, first of which is series. A series is a one-dimensional labeled array capable of holding data type of any, so it can be a string, a float, an integer, a Python object, etc. To create a series, you would use the following syntax: pd.series, open parentheses, closed. Make sure the s in the series is capitalized, that's fairly important. If you look on the right hand side, we have an example of a series. On the left hand side is the index, its default is numerically ordered, and then you have the element on the right hand side. So typically you put the data in the parameter. They usually would go in the format of a list or dictionary, but you can also put in individual strings, integer, or floats if you wish. And with series you can access individual elements, you can add elements, you can also replace elements, and you can also access methods using series. So let me hop on Repl.it and show you guys right now. So right now, as you can see, I imported Pandas. I created a list with 4 names: Eric, George, Bob, and Joe, and then I put that list inside the parameters. And then if I run this, okay, it's taking a while to install. We'll give it a sec. Cool. This is taking longer than expected. Alright, there we go. We have Eric, Joe. And then you can also print out individual elements. So right here you see, if I want to print out George, it has an index of 1. So inside this square brackets I'll put in 1. And then series is the name of the series I created earlier. You can also replace elements. So to do that, inside the square brackets, you would put an index that already exists. So what this line of code basically does is replaces George with Caroline. So if you can see here, I did just that. And then if you want to add elements inside the square brackets, you would have to put an index that doesn't already exist in the series. So in this case, I added an index of 4. So 4 is added, and then I can set that equal to whatever I want. In which case I added Andy, and then now Andy is equal to the index 4. With series you also have methods you can use, and then the documentation, which I'll link in the description, gives you a lot of methods that series provides. There's a whole list of them. If you want, you guys can check it out, but I definitely won't be going over all of them. In the example here I have one. I use the method called describe, and basically what it does is it takes your data and gives a brief statistics of your data. And then also one more thing I wanted to mention was you can also edit your index. So in the parameters there's this attribute called index, and then what this basically does is it allows you to set your index to whatever you want it to be. So in this case I have A, B, C, D, and then keep in mind that the number of indexes have to match the number of elements you had at the start. So I have 4 here, so I have to have 4 indexes. And so if I run this, it should print out the same thing except with the index ABC, and it does here, but we have an error. Okay, that's because since we have indexes A, B, C, D now, we no longer have an index of 1. So we're going to have to change that to either A, B, C, or D. I'll change that to B. And the same thing down here, change that to B too. And if I want to add a new element, it'll have to be an index that doesn't already exist. So I'll just put E for the sake of it. And now if I run this, it should, yeah, it does. So A, B, C, D, A, B, C, D, A, B, C, D, E. And now that's all we have for series. Let's jump into data frames now. So the second data structure in Pandas is data frames. It's a lot more predominant. It has so many more things you can do. And basically data frames is a two-dimensional data structure that contains both rows and columns. The syntax to create a data frame is pd.dataframe open parentheses close. The parameter takes in data, index, and columns. I won't be going over exactly what index and column does, but just keep in mind that if you don't have it, it'll be perfectly fine. The data can be in a form of NumPy arrays, series, maps, lists, dictionary constants, and even other data frames. With data frames, you can choose specific rows to print. You can also do operations with specific rows and columns, and there's a lot of other stuff you can do. Let me hop onto Repl.it once again and show you guys. So right now I created a data frame with this data list. So right here I have a list inside a list. So within each list I have a name, an age, an annual income, their profession, where they live, and their hobbies. And that would refer to the column, which is name, age, annual income, job, residence, and hobby. So if I comment these out, I'll discuss these in a sec, but I just want to show you guys what this will look like. So if I run this, okay, I did not mean to print this yet, but just ignore the bottom part. So if you guys see here, I have a data frame that contains this information. And as mentioned earlier, there were two ways you can edit indexes. I'll teach you guys the second way right now. So there is this method called setIndex, and what it basically does, it takes a column of your choice and that sets that as the index instead of the default index that goes from numeric order. So in this case, I want to set the column that's called name as the index. So if I do that and print it, see, it has name as the new index instead of the default. And then with data frames, you also have this method called ilock. And what it does is it allows you to print specific rows and columns by their numeric values. So what this line of code does is it prints out rows 0 to 2 and then columns 0 to 3. So if I run that, it prints rows 0 to 2, which is Alex and Bob, and then columns 0 to 3, which is annual, age, and then job. There's also this other method called lock, and it differs from ilocking that instead of taking numeric values, it takes labels. So you see here I have numbers, and here instead of numbers I have labels. So if I run this line of code, it'll print out rows 0 to 2, and instead of 0 to 3, it prints out the age and annual income. So these two are very similar, just keep in mind one takes in numeric values and the other takes in labels. You can also choose to print out specific rows by just doing df, which is the name of the data frame, open square brackets, close square brackets, and the rows you want to print with a colon to separate them. So this is saying I want to print out rows 0 to 2, so Alex and Bob. And then you can also choose to print out specific columns by putting the name of the column inside the square brackets instead of numbers. So if I wanted to print out the column age, I just do this. They should print out the column age. Yeah, it does exactly that. So Alex is 23, Bob is 30, Clark is 50. And then, as I mentioned before, you can also do math operations with this. So let's say I'm going to create a new column, and to do that, you would just do df square brackets and then a name of a column that doesn't already exist. So I would do monthly income, and the monthly income would equal the annual income divided by 12. And to actually access the annual income, you can just do a df open square brackets, close square brackets, and inside the name of the annual income. And then what this will do is it'll create a new column that takes the monthly annual income divided by 12. So if I print df now, it should create a new column. See, it creates a new column called monthly income. It basically took the annual income and it divided it by 12 and gave you the monthly income. So this just shows you how powerful Pandas is. Like, just with one line of code, it can do so much. And then another way to create a new column is by doing df, as I said before, and then a name of a column that doesn't already exist, and then you put a list with the information you want to put, but like the information in here has to be the same number of index you have. So if you have 3 indexes, you're gonna have to put three numbers, strings, or whatever inside. So now if I print this, it'll give me the number of kids each person has. So Alex has 1, Bob doesn't have any, and then Clark has 2. So that's basically what data frames is. And of course there's a lot more to it. I'm just giving you guys a basic overview and of how to use it. And once you guys understand this, you guys feel free to look at the documentation. It provides a lot more information in there. So next, we're going to look at how you can graph and create visualizations. So in order to graph your data, you actually have to use another Python module or library called Matplotlib. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. In particular, it's used for plotting. So often you use Matplotlib in conjunction with Pandas. And to import Matplotlib, you have to use the following syntax. It might be different from other libraries, but use it verbatim, please, because if not, it won't work. So if I go into Repl.it, let me import Matplotlib. So import matplotlib.pyplot as plt. And now if let's say I wanted to graph each person's annual income, I could do this. So df.annual income, this basically tells you the column you want to graph. And this plot method is a method that is specific for Matplotlib. That's why you needed to import it. And then what it does is basically plots your annual income. And then inside the parameters, you can actually specify what kind of graph you want. So it could be a line, a histogram, a bar graph. I'll just do a bar graph. So to do that, you would do kind, an attribute equals bar. Make sure that's in quotes. And then, just doing this won't actually do it. You actually have to use this method called show. Basically, it shows you, it puts it on the screen for you. So now if I run this method, it takes a while first time. If you guys see this message on Repl.it, don't worry about it. It's nothing much. It won't affect anything, so just be aware. So finally it loaded and it created a graph for us, a bar graph, that put their annual income on a graph. So you guys can see here. So that's basically all I have for this lesson. Thank you guys for watching this far, and hope you guys learned something.